Hi, hello everybody. So this is the video dealing with section 4.5, graphs of sine and cosine functions. Now, both functions are very similar, and I wanted to give you a little bit of an introduction, even though this was covered in the section 4.4. Imagine that you have a circle. Doesn't matter, this is the radius, doesn't matter if it's the unit circle or not. Imagine that you have a circle. And we have an angle here, whatever the angle name is, doesn't matter. And this is a point on this circle. Now, as this is moving, as this is advancing, it creates an X and Y coordinate everywhere as it's moving. Now, the value of the Y coordinate as this particle is moving on the circle is what we call the sine function. And the value of the x coordinate is what we call the cosine function. So this is a little bit of a review. This was covered in section 4.4, and you can take a look at the video uh, from that section. All that we're interested now is in now graphing the movement of this particle dealing with the y, or the sine function, or the x, the cosine function. Now, they're both, as we call them, periodic functions, and they're periodic because they repeat itself. So, for example, right, we are starting here and we're going around the circle once. When we repeat it, the particle is going to go over the same locations it did before. So it repeats. Okay, so normally when we graph sine and cosine functions, and you see later the other trigonometric functions, we don't want to graph from negative infinity to positive infinity because it's going to repeat a lot. So we are going to graph only one period of the function. So take a look at the picture right here. This is all that we're interested from the sine function. This is what the sine function looks like for one period. From here to here, the function is unique. Now, if we were to continue here, or if we were to continue there, the function would look exactly the same as this section, and it would look the same here, and it would look the same here, and so on and so forth, because it's periodic. Okay, so this is the information that we need to know. Number one, we need to know the look of the graph. So this is the graph of the sine function. And this is the typical function that we're going to be graphing. A function that has a coefficient in front of sine, and it has this information inside of the angle. Okay, instead of graphing just sine x, we're going to be graphing sine bx minus c. Okay, because this is the usual type of format that we see. Now, the amplitude of the function is the distance from the axis to its highest point, or from the axis to its lowest point. And this amplitude is the absolute value of the coefficient A. So even if it's negative, A is negative, the amplitude is the absolute value of A. Okay, the period is the distance from the beginning of the function to the end before it begins to repeat itself. Okay, so for the standard sine and cosine, the period is 2 pi. Okay, for the type of function that we are going to be graphing, which has format in here bx minus c, the period is going to be 2 pi divided by the value of b, this b right here. And this is the same thing for sine and cosine. Okay, so for both sine and cosine, even though we'll take a look at it later briefly, for both sine and cosine, the amplitude is absolute value A, and the period is 2 pi over the value or the coefficient B. Now, in graphing these functions, sine and cosine, we're going to need the amplitude, we're going to need the period, and we're going to have to graph 1, 2, 3, 4, 5. These are the 5 key points. So take a look at my notes right here at the bottom. So first, we'll identify the amplitude, the period, and the block size. I'll tell you what that is in a minute. We're going to find the starting point where we're going to graph. This is the starting point. Okay, so here your book correctly specifies this as the starting point. Okay, we are going to graph the function. If it is sine, it's going to look like that, and then we'll have to check if the sign is inverted or not, and I'll tell you what that is, reflected. And then we're going to identify and plot the 5 key points. So this is exactly the same procedure for sine and cosine, okay? All of these 5 things, 4 things right here. Now, what is this block size? Okay, so take a look at the graph again. 1, 2, 3, 4, 5 key points. These 5 key points split the whole either sine function or cosine function into 1, 2, 3, 4 blocks. So each of these blocks is 1/4 of the whole period. Okay, so once we find the period of the function that we're interested in, we're going to divide that period by 4, and then each of these little spaces or intervals is going to be whatever the period is divided by 4. And we're going to need that in order to find, once we have the starting point and we have the block size, all we have to do is start with the starting point and add the block size, add the block size, add the block size to find the other 4 key points. Okay, so it looks more complicated than it is. Once you see me do one problem, you see that this is extremely easy to do. Okay, so both the same sine and cosine. The function that we're going to graph for sine is this. Okay, and the cosine is going to be set. So let's take a look at a couple of examples. So I have here 2 problems that we're going to be doing, and I already have my sine function graphed. Okay, and I'll tell you exactly what to do. Now, on the exam, you won't have, obviously, the sine and cosine graphed. You're going to have to graph it yourself. The only thing I'm going to give you are the axes. The y-axis, supposed to be x, the y-axis, and obviously the x-axis. That's it. You won't have anything else. All right, so the very first thing that we're going to do, let's do example 4, is we have to find the amplitude. So the amplitude is, if you remember from before, is the absolute value of whatever this value is. So absolute value 4, which is obviously 4. Okay. Now we have to find the period. The period is for sine and cosine, and this is sine, is 2 pi over the value b. Okay. 2 pi for sine and cosine over b. Now, b is the number multiplying the x. So in this particular case, it's 2 pi over 2, which is obviously pi. Now, immediately after you find the period, you're going to find the block size. So I'm going to write here block size. And the block size is the period divided by 4, which means that each of these segments here for this particular function, the block size is not always the same, same as the period is not always the same. Okay, each of these 4 blocks is pi over 4. All right, now we have to start and find the starting point. The starting point is here. Okay. Now notice you are always going to graph, if it is a sine function, the way you are looking at this function right here with the starting point at the origin here. Okay. You're not going to offset it to the right or to the left. And we're going to label this location. This location is not going to be the origin, but you're going to graph it as if it is the origin because it's easier that way. All right. Now let's find the starting point. So starting point. So how do we find the starting point? The starting point is we are going to set the information inside of the sine function to 0, and we're going to solve it for x. So I'm going to add 2 pi over 3 to both sides, and I'm going to divide everything by 2. So this is pi over 3. So the starting point is pi over 3. Now, I'm going to write something here, but then I'm going to change it. The starting point, this location is pi over 3. I know that the block size is pi over 4. So this location here, the second spot, is pi over 3, obviously plus pi over 4. But we really don't want to add these fractions with, uncommon denominators. So what we can do, you don't have to do it, but I recommend you do it, that once you find the starting point and the block size, you should endeavor to have them both have the same denominator. Okay. So in this case, the common denominator is 12. So pi over 4 is going to become 3 pi over 12. That is the block size, right? 3 pi over 12 is 2 pi over 4. And pi over 3 is 4 pi over 12. All right, so 4 pi over 12 is still pi over 3. And pi over 4 is still 3 pi over 12. Okay? Now, Professor, why are you doing this? The reason I'm doing this is the following. Now, look how easy it is. Instead of writing the starting point as pi over 3, I'm going to write it as 4 pi over 12. Now, the next location is a block size away. Now, the block size is 3 pi over 12, so 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. The next point that we need to find is 3 pi over 12 away. So this is 10 pi over 12. The next point is 3 pi over 12 away. So 13 pi over 12. And the last one is 16 pi over 12. So we're almost done, right? I got all the 5 points. All I have to do now is make sure that the amplitude is reflected on the graph. So we need to mention that this location here is -4, and this location here is 4. Okay? And once I do that, my graph is completely done. Okay? I have the starting point, I have the highest point, I have the lowest point, and I have the 5 key points. I showed on my work, if this is an exam question, the fact that I know the amplitude, the period, the block size, and the starting point. Okay, so this is all that we have to do. Okay, and it's very repetitive. No matter what kind of function you have, either sine or cosine, the work is done exactly the same way. All right, so let's do the second function, which is very, very similar. I'm going to erase this one completely. And you see how identical it is. Okay, so notice that Now the coefficient is negative 3. So I have to find the amplitude. The amplitude is absolute value of negative 3, which is 3. Period is still 2 pi over b, but b now is 3. So my period is 2 pi over 3. And immediately I find the block size. The block size is the period over 4, right? So division of fractions multiplied by the reciprocal, and we get pi over 6. And now I have to find my starting point. Starting point. We know what to do. The starting point is we have to set 3x plus pi over 4 equals 0, and then we're going to solve that for x. So I'm going to subtract pi over 4 from both sides, and then I'm going to divide everything by 3. So here is my starting point, okay? Negative pi over 12. All right? Now, the starting point and the block size should have the same denominator because it's easier to add them that way. And in this case, it's very easy. The block size is pi over 6, so I change that to 12, which means I have to multiply the numerator by 2. So 2 pi over 12 is my block size. Now it becomes incredibly easy to graph. Okay, my starting point, this location right here, is negative pi over 12. Now be very careful. Notice that your function has a negative 3. Now, if you remember from graphing techniques that we've seen before, when the coefficient here is negative, this is a reflection on the x-axis. So the graph is not what you see here, is the reflection. So let's see if I can do this. This is the graph, okay? The black line, not the red. But the 5 key points are still the same. So we include in this point, and this point is positive 3, and we include in this point, and this point is negative 3, and all I have to do now is find in the other 4 points. Now, I already know the block size. The block size is 2 pi over 12. So the next point, the second one, is 2 pi over 12 from the negative pi over 12. So 2 pi over 12 minus pi over 12. So obviously this is pi over 12. Pi over 12. The next point right here is 2 pi over 12 away. So 3 pi over 12. The next point is 2 pi over 12 away, 5 pi over 12. And the last one is again 2 pi over 12, which is 7 pi over 12. So the technique is very simple, right? Just be careful and notice if you have a regular sign with a positive amplitude here or a positive coefficient or a negative when you have a negative coefficient right here. Okay, the rest is the same. Find amplitude, period, block size, starting point, and make sure that they have a common denominator. All right, so that's good. Now, the cosine function is exactly the same. The only difference from the sine function is that the cosine, again, remember it's it's a particle moving on the circle. And now we are interested in the x coordinate, okay? So the only difference is that the cosine is offset by 1/4 of the period. So instead of looking like the sine function, the cosine looks like this. Looks like this kind of V looking function. Okay. The 5 key points are still here. 1, 2, 3, 4, and 5. The amplitude, the lowest point is here. The highest point on the amplitude is there. Okay? The rest is exactly the same. The period is still 2 pi over the value b. The amplitude is still absolute value a. The block size is always period over 4. And we're going to find the 5 key points the exact same way. All right, so let's take a look at the two examples I have. It doesn't matter what this value is, what that value is, what this value is. Plus or minus doesn't matter. In this case, I think I have all positive, but I'm going to change it now so that you can see it absolutely does not matter. So right, one case I had a negative, this I have a positive. So I'm going to change one of these so that you can see that absolutely makes no difference. So I will change the first one to negative, but you've seen a negative already. So let's make this negative. Okay. And we'll leave this one positive. So let's do example 6. First function is cosine now. So the cosine is going to look like this. Okay. So you have to remember what the cosine looks like. And you're going to graph, this is the y-axis, this is the x-axis. And you're going to graph it from here, the origin, and we're going to relabel the origin with whatever value we get. Here are the 5 key points. Okay, so I already know the amplitude is absolute value 1/2, which is 1/2. So in here, I already put in 1/2, and this is the other location, which is negative 1/2. This is how high and how low the function can go. All right, so amplitude is here. Let's find the period. Period is 2 pi over the value b, which is 4. So this is pi over 2, right? Now, immediately after that, let's find the block size. Block size is always period over 4. So pi over 2 times 1/4, pi over 8. Okay, now let's find the starting point. Starting point. The starting point is we're going to solve. Just keep in mind, I changed this to a negative, okay? It doesn't really matter, but I wanted you to see one with a plus, one with a minus. So we're going to solve the equation inside of the sine or cosine angle, in this case for x minus pi. So I'm going to add pi to both sides, and I'm going to divide everything by 4. So my starting point is pi over 4, but my block size is pi over 8. So in this case, I'm going to change the starting point here to 2 pi over 8 to match, okay, to match the denominator of the block size. So now my starting point is 2 pi over 8, okay. I already have the amplitude positive and negative here. And each location on the graph is increased by pi over 8. So 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. Professor, do I have to simplify the fraction? Don't simplify the fraction because the graph looks better with the same denominator around. Okay, it's a lot easier for somebody to interpret the graph with the fractions unsimplified with the same denominator. It's much, much easier that way. And that's why I'm telling you this particular technique. All right, so this is it. This is the cosine. And notice when the coefficient is positive, this is the regular sign. And in the next case, we're going to see a negative coefficient. So the cosine is going to be reflected. So here is my amplitude. Notice that the amplitude is always the absolute value. So because of this negative, the cosine is reflected on the x-axis. All right, so this is the best I can do from this utility here, from this app. But this is what all we know so far. This is 6 over 5 positive. This is negative 6 over 5. And these are the 5 key points. 1, 2, 3, 4, and 5. Now let's find the period. 2 pi over b. And in this case, b is 5. Can't simplify this. And then the block size, which is the period over 4. So 2 pi over 5 times 1/4. Obviously, this is pi over 10. Okay? So the block size is pi over 10. Let's find the starting point. So the starting point, I solved the equation 5x plus pi over 2. So minus pi over 2 to both sides. And divide everything by 5. So here is the starting point. And notice, just a coincidence maybe, that both denominators are already the same. So this is the easiest possible case. You don't have to do anything. You don't have to find a common denominator because both have the same denominator already. So I'm going to start at the negative pi over 10. And notice, you don't have to shift anything. You're going to graph it as if this location here is your origin. And we just relabel it with the starting point. So negative pi over 10, and then each successive point is pi over 10 away. So I'm starting with negative pi over 10. The next point is pi over 10. I'm sorry. The next point is pi over 10 plus the negative pi over 10. So this is 0. The next point is pi over 10 away. The next point is pi over 10 away. And the next point is pi over 10 away. Okay, so negative pi over 10, 0 pi over 10, 2 pi over 10, 3 pi over 10. If you want, you could do 0 pi over 10, but it's unnecessary. You can just write 0. Okay, so this is the graph of the reflected sine. I'm sorry, cosine. Now, I'm sorry, I think I wrote sine here, but obviously I meant to write cosine. All right, so sorry about that. And this is all you have to do. So recapping, find the amplitude regardless if you have cosine or the sine function. Okay, you are going to find the amplitude. Okay, find the amplitude. And then you're going to find the period. The period is always going to be 2 pi over the value b. Find the block size, which is period divided by 4. Find the starting point, which is you're going to solve this equation, okay, equals to 0. And then, if necessary, make sure that the denominator of your starting point matches the denominator of the block size. Graph the function. If it is cosine, it would look like this. Okay. If it's negative cosine is reflected. If it's the sine, it's the one you've seen before. Okay, it's up here. Okay, if it's sine, is this one. And if it's the reflected sine, it's the other one. And put in the 5 key points. All right. So this is all that we have to do. Nothing else is necessary. You're going to be graphing exactly the same way as I did it over here. Make sure that you include the highest point and the lowest point, the 5 key points, and the correct graph reflected or not. And this is how we graph these two functions, sine and cosine, in this format. This is the most complicated format, and this is the one that we're going to see in our exams.